In example 5, we want to finding the inverse of a radical function. So how do we go about that when you're given a radical function and then finding the inverse? Step 1, you're going to determine the range of the original function. Replace f of x with y, then solve for x, and then if necessary, restrict the domain of the inverse function to the range of the original function. So, we're going to restrict the domain of the function f of x, which is equal to the square root of x minus 4, and then find the inverse. Now, let's take a look at the range here. Notice that the original function has a range, f of x, which is greater than or equal to 0. So remember that the range is the y value. So it's starting at 0 and it's going all the way up to positive infinity. So therefore, that's why the range is f of x is greater than or equal to 0. So what we're going to do is then we're going to now replace f of x with y and then solve for x by following the inverse steps. So step 1, we replace y with f of x. So now y is equal to the square root of x minus 4. Step 2, we are interchanging x and y. So we have x now is equal to the square root of y minus 4. And then in step 3, since we want to solve for y, we need to get rid of that y under the radical sign. So we have to square each side of the equation. And so we end up getting x squared, which is equal to y minus 4. Now again, we still have to solve for y. So in order to solve for y, we end up getting y is equal to x squared plus 4. So f inverse of x is going to equal x squared plus 4. Now recall that the domain of this function must be limited to the range of the original function. So we need to make sure that that restriction also applies when we find that inverse. So f inverse is going to equal x squared plus 4, but it's not a solution until you put in that restriction. And that restriction means that x is greater than or equal to 0. Now, let's take a look at this. So notice that in the figure 8, that the inverse is a reflection of the original function over the line y equals x, because the original function has only positive outputs. So the inverse function has only positive inputs.